Hello everyone, welcome to lessons 11 and 12. And so we will begin with lesson 11, normal distribution 1. Now this is a very important distribution. Remember we looked in the previous lesson on probability distributions where we had a table. We made a table and we list all the possible outcomes of a variable and their corresponding probabilities. Right? Now with that, those tables represent probability distributions for discrete variables. Remember, way at the beginning of the semester, we looked at variables and we classified them as discrete or continuous. If the variable is discrete, then you can list all the values, right? That's the definition of discrete. You can list the values, and you can therefore make a table with all the values and their corresponding probabilities. When the variables are continuous, you cannot list all the values, so the probability distribution cannot be a table. It ends up becoming a shape, a curve, right? And we will study a number of curves in this course. Well, in fact, we will only be studying the normal distribution, one curve, the bell curve, right? If we were in class, we would have gone over a number of different curves, but because we are online and you're studying alone, we will limit it to the normal distribution. So let's just see the standard normal distribution or the standard normal curve, right? A normal distributed variable having mean of 0, the mean of the data set is 0, and the standard deviation is 1, is said to have the standard normal distribution. Its associated normal curve is called the standard normal curve, which is shown in the figure below, right? So what does it mean for a data to be normally distributed? Normally distributed variables in normally distributed variable, the mean, median, and mode are equal. This is just some characteristics. There are more, but this is an important one, right? And if a histogram is to be made, the shape would look like a bell. You know, the bars would make a shape that looks like a bell, like what we see below, right? Now the mean, the median, and the mode, they're equal but do not have to be 0. The mean does not have to be 0, right? So whenever it's a 0, then it's a special normal distribution. It's called a standard normal distribution, right? So the standard normal distribution is a normally distributed variable whose mean is 0 and whose standard deviation is 1. There are normal distribution that has a mean of 20, for example, and a standard deviation of 5. That will not be the standard normal distribution. It will just be a normal distribution. Okay, so to make it standard, the mean must be 0 and the standard deviation must be 1. Okay, now as you can see, this is the graph or the shape of the standard normal distribution. Now the area under this curve, if we were to calculate the area here, it will be 1. Okay, and we need calculus to do that. So for now, we're just going to assume that we accept that the area is 1, right? So if I want to know what space I have under this curve, even though it goes on forever in this direction, right? It goes on forever. It never touches the x-axis. It goes on forever. And it goes on forever. Still the area is 1. It goes to 1. The limit is 1. And what we want to do when we talk about normal distribution probabilities, we want to find the area under this curve. The area under the curve, right? Like this little, for example, if I'm to draw a line here, through 0, right? Through 0 here, the area on the left side would be 1/2, right? The area, because the whole thing we know is 1. So if I'm to cut it in the middle here, the area on the left side would be 1/2. The area on the right side would be 1/2, right? So before we go further, I want to show you how to use table 2. Table 2, calculate the area starting from this end, right? Starting from this end, it calculates the areas. You go a little bit at a time and write it down on table 2. So for example, it's telling me, by the way, the z-scores we did in a previous lesson, z-scores, right? Now you have a table attached to your lesson handout. Now this value here, you see it says 0 here? What does this mean? It means, first of all, it has a z-score, right? Z-score, and the z-score is negative 3.90, right? Look, negative 3.9, and then the last digit is the last digit that you see here, right? You can imagine the zero, it's like 3.90, right? So take this number that you have here and add the last digit that you see in this number here to it, and that's the z-score. So this is telling me that to the left of 3.9, to the left of negative 3.9, there's no area, right? So you see we have negative 3 here. The left of negative 3.9, like here, there's no area there. There's 0 area. There is a very small area, but it's negligible, right? To 4 decimal places. If you were to round your answer, if let's say the people who made this table rounded their answer to 20 decimal places, then it would have maybe not be 0 exactly, right? It would be maybe a bunch of zeros, like maybe 12 or 13 zeros and then some number. But if you round to 4 places, it's 0, right? Now, each of these values here, this is the body of the table. They represent area under the curve, right? These numbers are the body of the table. Each of these areas have a corresponding z-score. And guys, pay attention. Get your pen and paper if you need, because this is important. Now, what's the z-score for this number here? I'm not allowed to make notes on the PDF, but what's the z-score for this number that I've highlighted? It's negative 3.4, negative 3.45, negative 3.45. That's the z-score for this area. It means that this z-score, negative 3.45, has this area to its left side. This is what the table is showing you. If you make this z, if you replace the z here and you put negative 3.45, then the area that's shaded there is 0.003. The table always gives you the area that's on the left side of the z-score. A little bit more. If you move forward a little bit, see, because if you move forward 3.46, 3.47, you're not really getting any more area. You barely move a little bit because of the nature of the curve, right? Sometimes you jump a big space, sometimes you barely move. Like here, we didn't move at all. Then the area to the left of negative 3.49. You guys see that this here, the area to the left of negative 3.49 is 0.002. Okay, now what is the area to the left? Let me give you some exercise to do. You'll do it together. What is the area to the left of negative 2.63? What is the area to the left of negative 2.63? Find it in here. It's in here somewhere, right? What is the area to the left of negative 2.63 is what I said, right? Negative 2.63. So we go negative 2.6, 0, 1, 2, 3, right? Negative 2.6, 0, 1, 2, 3. This is the area to the left of negative 2.63, right? Imagine you draw am I allowed to make it? It's going to be difficult. Let me see if I can make a drawing here. Okay, it's going to be poor, guys, but I'm going to try my best, okay? negative 2.6, negative 2.6 is what I said. Let's say that's negative 2.63, right? That's the z-score, and I want to know what's this area here, right? What's this area here? And we said it's going to be 0, 1, 2, 3, right? The area here is 0 0.0043, right? That's the idea. It always gives you the area to the left side of the z-score. So if we know that the area on the left side is 0.0043, we also know what's this area here because the whole thing is 1, right? So what would be that area? It would be 1 minus 0.0043. And what is that? 1 minus 0.0043 is 0.9957. 0.9957, right? So the area on the left side is 0.0043. The area on the right side is 0.9957. So once you know the area on the left side, which will always be given from the table, right? Then the area from the right side can be calculated by minusing 1 from the area on the left, right? That's all we can do to find the area on the right side. Now, what's the area in the middle? Let me just verify for you that if you go why doesn't it move? Oh. How do I get this? Maybe I click it again. Good. The area to the left side of 0, remember 0 is in the middle, right? The area to the left side of 0, we know it's going to be 1/2, which is 0.5, right? And you can see it on the table. 0, no matter the negative sign, 0 doesn't have a sign, right? The area to the left of 0.00, remember this first column is 0, right? So the z-score would be negative 0.00, right? Because you take whatever number you have here, add the last digit. So the area to the left of 0 is 1/2, as you can see, rounded to 4 places. So we will come back to this table a lot, but I wanted you to get an idea of how to use the table, right? It has a z-score, and remember, it's the same z-score that we calculated before, x minus the mean divided by the standard deviation, right? Remember, that's what we did in one of our lessons. Okay, so this is the standard normal curve, and we're interested in finding the area on different parts of this curve, right? And later on, you will see that becomes probability. All right, so we have the basic property of the standard normal curve. The area, the total area under the standard normal curve is 1. The standard normal curve extends indefinitely in both directions, approaching but never touching the horizontal axis as it does so. So it goes on forever, right? It goes on forever, but it never touches this axis. It's always a space between the x-axis and the curve. Property 3, the standard normal curve is symmetric about 0. That is, the part of the curve to the left of the dashed line is a mirror image, right? So we didn't have the line here, but if we were to draw a line here through 0, right? If we were to draw a line through 0 and fold it over, the left half would lie neatly on top of the right half. That is what it means to be symmetric. Okay, and then almost all of the area under the standard normal curve lies between -3 and +3. So between -3 and +3, you have almost all the area. 1, right? So you have like 0.99 something, because very little area exists today to the left of -3. To the left of -3 or to the right of -3, right? Almost all. There's a tiny amount that's there. Okay? Now let's actually show how we will look at it. Using table 2, right? Table 2 gives the area under the standard normal curve that is to the left of each z-score, right? We have to remember that fact. Table 2 gives the area under the curve, under the standard normal curve that is to the left of each z-score. So let's look at this example together. We need to sketch a curve. Now this notation is important, guys, right? It means a normal distribution. The first number is always the mean, and the second number is the standard deviation, right? So we have a normal distribution with a mean of 100 and a standard deviation of 10. It is not the standard normal distribution because the mean is not 0 and the standard deviation is not 1, right? So it's just a normal distribution. The first thing they said to do is to sketch it. So we sketch it. Look what I did. The mean is in the middle, 100, right? The mean is 100, and I make the scale in increments of the standard deviation, which is 10. So I count in tens. Just like up here, where the standard deviation was 1, the mean is 0, and the standard deviation is 1. We count in ones, right? So 1, 2, 3, because the standard deviation is 1. Negative 1, negative 2, negative 3. Whatever the standard deviation is, that is by how much you count by, right? So the mean is 100, that goes in the middle. Then to add 10, you have 110, 120, 130. Then you subtract 10, you have 90. Subtract another 10, you have 80. Subtract another 10. And then you draw the curve. Remember, we go up to 3 standard deviations below to 3 standard deviations above because almost all of it is there. We don't really need to go further. And you draw a nice curve above it that looks like a bell. Make sure that the highest spot is above the mean. Okay? Now, the next question I want us to do, what is the area to the left of 60? Right? And I'm saying that the area is 0, rounded to 4 places. So this is what we do. We already know how to calculate z-scores, right? Let me remind you of that formula. The z-score, we did it before, right? Z is equal to x minus the mean. Remember, we have a symbol for the mean. Look back at that lesson, divided by the standard deviation. We do have a, that's the formula for the z-score, right? So we have the mean is 100, standard deviation is 10, and the value that they're giving us would be our x value, whatever that, what's the x is. So what is the area to the left of 60? Now look at what we did here. I did it on paper to give more explanation. This is my curve, the x curve, the normal distribution. We want to convert it to the standard normal distribution, right? Well, 60, the area to the left of 60, correspond to the area to what on table 2? For us to use table 2, we need the z-score for 60. Well, the z-score for 60, we calculate the z-score, it's 60 minus the mean, divided by the standard deviation. It's negative 4.00. Well, they already told us if the left of negative 3.9, let's say this is negative 3.9 here, if the left of that is 0, certainly if you go beyond to the left, if you go more to the left, you'll still have 0, right? Because already at negative 3.9, it's 0. So if you go further left, you're still not going to have anything more there, okay? So that is why the area to the left of 60 is 0, right? What is the area to the right of 140? The area to the right of 140. Well, again, it's going to be 0, and I'll show you why. Right? Again, 140. I'm interested in the area on the right side of 140, but I can't use table 2 using 140. I have to use the z-score for 140. So I've calculated the z-score for 140. 140 minus 100 divided by 10, right? X minus the mean divided by the standard deviation. And we have 4. So I need the area to the right side of 4. Well, I know the area on the right side of, oops, sorry, wrong place. In fact, let me show you in the table. The area on the left side, right, of positive 3.90 is 1. They have the whole thing here, right? So to the left side of See this area that I didn't shade? Remember, you have to remember that the whole thing is 1, right? But to the left of 3.9, let's say the unshaded region, that is already 1. So that means we have nothing on the right side. Right? It's a little bit strange when we start doing the normal distribution, but it gets better. Remember, they're saying 3.9 to the left of 3.9, you have the whole area, 1. You can't get any bigger than 1. That means to the right side of it, you don't have anything. Okay? What that is saying is that, bear with me guys, it's a little bit messy. This here, let me do it over here, a little bit more space. Let me do it here so you can. This is 3.9, right? This area here, all the way here, all this, right guys? It's hard for me to write with the cursor, is 1. The area is 1. Right? The area is 1. Remember, it's a normal curve, right? So therefore, since we know that the entire area is 1, we already have 1. It means on the right side here, there's no area there. The area is 0. So certainly at 4, to the right side of 4 would also be 0. There's nothing there, right? Because to the left side already has everything, right? So the area to the right side of 140, right, is 0. Right? Now, the area to the right side of 140. What did they ask for? I'm sorry. The area to the right side of 140 is 0. Right? The answer is 0. Right? So what am I supposed to show here? There's a little bit error here, guys. There's a little bit error. It should have been 1 minus 1. Right? It should be 0. Yeah, but there's no error, right? There's a little error in the picture. Okay, next one. What is the area between 73 and 125? Well, between 73, I made a mistake here again. Right? I did 70 and 125. So let's change it then. 70 and 125, right? 70 and 125. So 70 has a z-score of -3, and 125 has a negative 3.00 and 3.00, right? I'm sorry, 2.50, right? So first, the area between 70 and 125 is going to be equal to the area between two different values, the z-scores. So 70 correspond to -3, and 125 correspond to 2.50, right? So how do we find the area between the two of them? Find the area for 2.50. So go ahead into table 2 and find the area for 2.50, right? 2.50. 2.5, that's this number here. That's the area to the left side, right? 0.9938, right? 0.9938. That is the area to the left of 2.50. So what is the area to the left of -3.00? -3.00, that's the area here. This is the area to the left of -3.00, right? 0.0013. You subtract those two areas, and then you have the area what's in between. Now, let me explain why, guys. So you have to remember that to find the area between two values, You find the area for the one on the right side, find the area for the one on the left side on the table, subtract the two answers. And this is the reason why. When you find the area to the left of 2.50, you have the shaded region and this little unshaded region here as well, because it always gives you the area from the left, starting here and all the way to the left, right? Understand that? You will get the shaded area, but you will also get this little piece too. We don't want this little piece, so we need to subtract it off. Well, the little piece is the area to the left of negative 3.0. So that is why we find the area to the left of 2.50, get everything, the shaded region here and the unshaded region there. We don't want this little piece here, so that is the area to the left of negative 3. So we find the area to the left of negative 3, subtract it from the area to the left of negative 2, from the area to the left of positive 2.50. So this is the area in between. Okay? This is the area in between the two. Okay? So first you find the z-score for each value, then look into the table for the area associated with those z-scores and subtract them when you want to find the area between two of them. Okay? What is the area either to the left of 80 or to the right of 110? The area either to the left of 80 or to the right is equal to the area to the left of, well, 80 has a z-score of negative 2.0. 80 has a z-score of negative 2.00. Or, this is important, or to the right of z equals 1.00, right? Two separate cases. So what's the area to the left of 80? We need to find the area to the left of negative 2.00, right? We need to find the area to the left of negative 2.00. So the area to the left of negative 2.00 is this area here, right guys? Negative 2.00 has this area to its left, right? Negative 2.0, and the first column is 0, so this is the area to the left of negative 2.00. So this little area here is that. Now the area to the right of 110, the table will give us the area to the left when we look for the z-score 1, right? It will give us the area to the left side. We don't want the area on the left side, we have to get the area on the right side, so we must 1 minus that area, right? So when we calculate the z-score for 110, the z-score is 1. But if I look for 1.00, I have this number here, right? But this is not the area on the right side of 1, it's the area to the left side, right? So that's why that's the 0.8413 represent this area here and these two pieces here on the left side. If I want the right side, since the whole thing is 1, I do 1 minus what's on the left, and I have 1587, 0.1587. So to find the area of these two shaded regions, I add them, right? I need to add this area to that area, and that's what I did here to get 1815. So when it's on the outside of 2, you add them. When it's between the two, you subtract them. See the two different cases here? When it's between the two, you subtract the two answers you get. When it's on the outside, like here, you add the two answers. You could have actually find the area between the two of them, right? And subtract that from 1, and you will get what the two outside 1 equals to. That's another way to do it, right? Why don't you find the area, this unshaded area here? What is the area between the middle? And then since the whole thing is 1, when you minus that answer from 1, you should get what these two pieces equal to. If you don't understand what I'm saying, just do it how we did it in this question here. Okay? What is the area at 90? This is a special problem. What is the area at 90? There is no area at 90. A line here. Imagine if this was a cake, right? If this was a cake and you cut it at 90, there is no cake at 90 itself. You must specify either to the left or to the right or in between, right? So when it says area at or equal at some value, right? The answer would always be 0. Right? And we do the same again. Right? So if we sketch the curve, I'm going to go over this one quickly too, because I want you to work it out on your own and check the answer. So we sketch it. The mean is 50. Standard deviation is 5. So I put 50 in the middle, 55, 60, 65, and so on. Right? Then what is the area to the left of 35? Area to the left of 35. Find the z-score for 35. Negative 3.00. Negative 3.00. This is the area to the left of it. Right? So the area to the left of 35 will be 0.0030. 0.0013. Right? To the right of 65, same thing. Now I corrected it here, right? The area to the, I made a mistake in the first one, which I'll correct in a little bit. So first we find the area on the left side of 3. What's the area to the left side of 3? 0.9987. The area to the left side of 3 is this number, right? 0.9987, negative 3.00. But I don't want this. I want what will be on the right side. Remember, the table always gives us the area on the left side, right? So the table gives us the area on the left side, the unshaded area. We want the area on the right side. So it's 1 minus the area on the left side, which you get 0.0013, right? The area between the two of them, between 48 and 61, well, the z-score for 48 is negative. Look, I did the calculations here. It's negative 0.40. And the z-score for 61 is 2.20. So to find the area between two values, I need to find the area for 2.20. So 2.20, 2.2, 2.20, that's this number here, right? 2.209861. Then I find the area for negative 0.40. Find the area for negative 0.40. Negative 0.40. Where is it? Negative 0.4. Negative 0.40, that's this number here. 0.3446. And subtract it 2. Right? 0.3446. When you subtract it 2, you have the area in between. So the area between is 0.6415. Right? The area on the outside. What is the area either to the left of 44 or to the right of 72? Okay, so the z-score for 44 is 1.20. Negative 1.20, sorry. Negative 1.20. And the z-score for 72 is 4.40. Right? What's the area to the left of negative 1.20? Negative 1.20 is this first number here. It's 0.1151. That is the area to the left of 1.20. This area that I have here. The area to the right of, we know that anything beyond 3.9 is going to be 0, right? Anything beyond 3.9. Look, the table, anything at 3.9, we have 0. I have the whole, we have 1, right? At 3.9, we have, remember, this is the area on the left side. If the left side of 3.9 is 1, the right side of 3.9 would be 0. Because the whole thing is 1. Don't forget, the area under the whole curve is 1, right? The area under this curve, the whole curve is 1. So if you come to 3.9 and you have 1 already, it means on the right side of 3.9 you have nothing. So any number bigger than 3.9 will not have any area on its right side. So the area to the right of 4.40 is 0, and you add the two pieces. You get 0.1151. Okay? At 62, remember, when it says exactly at some number, it will always be 0 because there's no area that's specified. Right? Now these are the three main cases here. Read these, right? So to find the area to the left, whatever area you get in the table, right? The table will give you this value. When you want to find the area to the right side of a z-score, whatever area you get from the table, because the table always gives you the area to the left, you minus it from 1. And when you want to find the area between two values, find the area to the left of this one, find the area to the left of this one, and then subtract the two answers, right? Subtract the area from the second area from the first area, right? So that is what I've explained. How to do the pictures are explained here. Okay. And that is the end of lesson 11. Let me go back and correct that one. And it's too bad that I wouldn't be able to get a picture there. The picture here is off, right? It should not be 1, right? So let me remove the picture so we don't have it, right? And let me see if I can actually draw it. Okay, everyone, so I went back and I corrected this question. The error was here, it was written incorrectly. So we want to find the area to the right of 140. So 140 has a z-score of 4.00. Now the area to the left of 4 is 1, right? Because on the table, at 3.9, we already have 1. The area to the left of 3.9 is already 1. So if you move beyond 3.9, it will still be 1. You cannot accumulate anymore because the area of the under the entire curve is 1. So if you go to 4, you still get 1 because 4, when you move from 3.9 to 4, you're not getting any more area, right? You have already have all the area to the left. So the area to the left is 1. So if you want to find the area on the right side, 1 minus 1, right? To give me 0. So the area to the right side of 4, even though I shade something here, it's negligible. It's very small. To 4 decimal places, it's 0. Okay, so that was the correction I wanted to make. And I think we're finished with lesson 11. Now lesson 12 is the same, more practice of what we've been doing. So lesson 12, right, finding the area. So what's the area? Go ahead, guys. Pause the video and find it. What's the area to the left of negative 0.99? The area to the left of negative 0.99. Negative 0.9. Negative 0.9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's 1611. The area to the left of 0.99 is 0.1611, right? So we have B, 1.96. What is the area to the left of 1.96? Go search for 1.9 and then go over to 6. 1.9 and go over to 6. 1.9, 0. Don't forget you start at 0. 1.90, 1.91, 1.92, 1.93, 1.94, 1.95, 1.96, 0.9750. The area to the left of 1.96 is 0.9750. Okay? The area on the right side of 1.28. The area on the right side of 1.28. The right side of 1.28. So find 1.2, 1.20, 1.20, 1.21, 1.22, 1.23, 1.24, 1.25, 1.26, 1.27, 1.28, 0.8997. But remember, this is not the area on the right side. This is the area on the left side. 0.8997. That's this area here, the unshaded area. If I want the area on the right side, since I know the whole thing is 1 minus 0.8997 gives me 0.1003. So this shaded area here is 0.1003. Okay. What is the area on the right side of negative 1.14? The area on the right side of negative 1.14. Okay, we go to negative 1.1. Negative 1.10, 1.11, 1.12, 1.13, negative 1.14 is 1271. Again, remember though that is the area on the left side, 0.1271. Oh, did I count it wrong? Negative 1.14. Negative 1.10, 1, 2, 3, 4. 0.1271, right? So I have an answer here. It's 11271. Negative 1.14. Negative 1.14. Let me double check, right? Negative, it's good to make a few mistakes so you see the correction. Negative 1.101234, 0.1271, right? 0.1271. But remember, that is this area here that's unshaded. So to get the area on the right side, we must minus that from 1. So 1 minus 0.1271, 8729. The calculation is correct. There was a typo, 0.8729, right? 1 minus 0.1271 is 0.8729. That's correct. Okay? So remember the area on the right side. Now how do we find the area between the two values? Right? Find the area to the left of 1.25. Go ahead into table 1.25 and see what you get. 1.25. 1.2, 0, 1, 2, 3, 4, 5, 0.8944, right? The area to the left of negative 1.50, negative 1.5, 0 means it's going to be the first number, negative 1.5, this line here, 0.0668, negative 1.50, right? 0.0668. To find the area between the two of them, you subtract this area, the area for this smaller number from the area of the larger number, right? So 8944 minus 0.0668, you get 0.8276. Similarly, the area between 0 and 1.54, you do the same thing. I leave it up to you to check, but let me do it just so I make sure I have the correct answers here. So the area to the left of 1.54, 1.54, 1.5, 0, 1, 2, 3, 0.9382. So the area to the left of 1.54 is 0.9382. The area to the left of 0. 0 is in the middle. Remember, 0 is in the middle. So you could either find it here, the area to the left of 0 is here, and then they also double it up again. They mention it again up here, the area to the left of 0. Because negative 0 and positive 0 is the same number, right? It's a half. So the area between will be the area to the left of 1.54, which is 9382, minus the area to the left of 0 is 0.5, and minus you have that. 9382, let's see here. 0.9382 minus 0.5, 4382. 4382 is what the answer should be there, 0.4382. So that's the area between. Notice we're going over these cases, right? Area to the left, area to the right, area between. Then we'll do area on the outside, either to the left of negative 2.34 or to the right of 2.16. So let's see here. We have to make the picture here. To the left of negative 2.34, 2.30123 0.0096. That's what we have here. To the right side. Now, how did I get 0.0154? First, we find 2.16, 2.1, 0, 1, 2, 3, 4, 5, 9, 8, 4, 6, right? But remember, 9846 is the area to the left side. We want this area here, so we minus it from 1. 1 minus that is 0.0154. So we add these two areas to get the final answer, 0.0250. Okay? Then we do the same thing for B, negative 3.33, negative 3.33, 0.0004. All right, the area to the right side of 1.37. So we find 1.37 first. 1.37, 0, 1, 2, 3, 4, 5, 6, 9. But that is the area to the left. If we want the area on the right side, we minus this number from 1. And that's what we did here. 1 minus 9147. And we get 0.0853. So to find the area either to the left of that or to the right of that, we add these two areas, and that's what we have. What would be the area at z equals? Remember, when it says at some specific z value, the answer would be 0. There's no area there, right? There's no area at the z-score. You have area to the left or to the right or between or on the outside of two z-scores, but never at a specific z-score. Okay, now another question, I have to reverse the order. We need to find the z-score, right? We need to find the z-score if they give us the area. It's the reversal. Before, they give us the z-score and we found the area, right? Other times, they will give us the area and then we might have to find the z-score. Now, sometimes we can't find the exact z-score. We'll have to estimate it, right? We will have to estimate it if we can't find the z-score. So how will we do that? Let's look at some specific cases. What z-score has an area of this on its left side, and of course it will have that on its right side, right? So sketch a picture. The z-score has 0.9950 on its left, and it has this on its right, because the two sides must add up to 1, right? So what is this z-score? So we have to go in the body of the table, and we have to search the body of the table for that number. What are we looking for? Since the table always gives us the area on the left, we need to look for this number here so that we can get this z-score. If I look for this number here, I will get a z-score that's over here somewhere, right? Because it has this area on its left. So we need to get the area on the left of the z-score. 0.9950. 0.93, and it's in order, right? 93, 94, 95, 997. Let's keep going. 0.99 starts somewhere here. What are we looking for? 0.9950. 9948, 9949, 9951. Okay, so it jumps from 0.9949 to 0.9951, right? Table doesn't have 0.9950. So what we will do, since 50, right, is exactly in the middle between these two, this is the logic, and make sure you replay me if you need to. Maybe I explain it in the document here. It jumps, right, from 9949, 9951. Well, 9950 is exactly in the middle between these two. So its z-score must be in the middle of these two z-scores, right? The z-score for 9949 is 2.57, right? 9949. What's the z-score for this number? It's 2.5, 0, 1, 2, 3, 4, 5, 6, 7. It's 2.57. And this one, the z-score is going to be 2.58, right? 2.57, 2.58. So the z-score for 9950 has to be in between the two of them. So to find the number that's between the two of them, you add the 2 and divide by 2, right? So add the two z-scores, divide by 2, and you get this number here, 2.575, right? That is this number that's between, exactly in the middle between these two. But we always round our z-scores to 2 places, right? But if we round this number to 2 places, we get back this one here, which is fine. So this is what we will use, right? So when it's exactly in the middle, see, it wasn't closer to any of them. It was exactly in the middle. This is the technique we have, and you will see a pattern. You will see that it'll always come out to be this number here. But do the calculation as we did here always, right? And then round your answer to 2 places, right? So it's 2.58. So this the estimate that it's an estimate, right? It should be 2.58. Right? So the z-score that has 0.9950 on its left side is 2.58. Okay? Similarly, what z-score has an area of 0.9900 on its left, and of course it'll have 0.0100 on its right? So you draw the picture here, and we need to look for 0.9900. Let's go 0.99. 0099. You always want to go one that's below 1 then, right? So it goes from 9898 to 9901, right? It jumps. We don't have 9900 here, right? Is that what it says? 9900 is what we're looking for? Yes. It's not in the middle. Is it closer to one of these two? So 9898 is 2 away, right? 9898, and you have 9899, then 9900. So it's 2 away, right? It's closer to 9901. Yes, 9900 is closer to 9901 than it is to 9898. Right? One is 2 away, and the other one is only 1 away. So we use that estimate. You know it's going to come out to be this one. Right? So what's the z-score for this one? 2.33. Notice that this case is different from the previous case where it was exactly in the middle. It's not exactly in the middle, right? 9900 is not exactly in the middle between these two numbers, right? It's closer to one of them, right? 9898, 9901, 9900 is closer to this one, so we use the same z-score, 2.33 for 9901 has a z-score of 2.33. Is that true? 2.30123, right? (9750) what z-score has an area of 9750 on its left and 0.0250 on its right? So let's look for 9750 in the table. 97. This is 98. 97, 26, 40. No, this one is actually on the table. Look at that. It's on the table. 9750. So what is the z-score? 1.90123456. 1.96. So the z-score here is 1.96. Right? Has 9500 on its left side, 0.9500 on its left side. So that's like saying it has 95% on its left side and 5% on its right side. What's the z-score? So we must always look for the area on the left here, right, of the z-score. When we want to find the z-score, you have to look for the area that's on the left of it in that table. So we look for 9500. 9500. Similar situation as the first case, right? We have 9495, then 9505. 9500 is exactly in the middle of those two numbers, right? Make sure you understand what I'm saying. It is exactly in the middle. So we will have to find a z-score that's exactly in the middle of the two z-scores here. I believe I explained. 9495, then the table jumps to 9505, right? 9500 is in the middle. Well, 9495 has a z-score of 1.64, 1.6, 0, 1, 2, 3, 4, and 9505 has a z-score of 1.65. We know our calculation will end up being 1.65, but let's verify it, right? So the z-score in the middle has to be between these two, right? So add the two of them and divide by 2. You get 1. This is it exactly, but we round z-scores to 2 places, so it turns out to be 1.65 as an estimate, right? Round it as an estimate. What z-score has an area of 9,000, or 0.9 on its left, and 0.1 on its right? Right? So we're looking for 0.9000. So I have to go back to 8. Oh, look here. It jumps from 89.97 to 90.15. 89.97 to 90.15. That's what the table jumps, right? We want 9,000, so I'm going to ask you the question, which 9,000, 0.9000 is closer to which of these two numbers? Well, it's 3 away from this number and it's 15 away from this number. So we have to use this one as the estimate, right? So what's the z-score for this number? It's 0, 1, 2, 3, 4, 5, 6, 7, 8. It's 1.28. The z-score for this number, which 0.9000 is closer to, is 1.28. And that's what we have here. Okay. All right, so for homework, you don't have any classwork. We did a lot of practice already. So this is the homework. Remember, this question is in Canvas. You will complete this question in Canvas. Remember, on homework, you have 2 attempts, right? Remember, you have 2 attempts, right? And you get to keep higher score. But must complete both attempts by deadline. Okay? So this is the homework question, right? And then it's June 15, 11:59 p.m. Okay, so there we have it. We had another video, 2 lessons together. So watch it a little bit at a time. Pause the videos as you need, and work the questions. Practice. Remember, you must read the textbook as well, right? I've sent an announcement with a PDF version of the 8th edition of the textbook. That could be useful for you, a little bit easier to use online if you find that it's difficult to use the e-text that's in Canvas. Okay, I hope you all have a wonderful week, and I'll look forward to hear from you through email and Canvas. Take care.